Okay? Doing this integration, just as an example. So here's the integral. I don't have to read it to you. The parentheses here are really there just for clarification. It can be written with or without the parentheses that I just put in there. We integrate this thing with respect to y between these limits, which means we treat x as a constant and integrate with y as a variable. So our antiderivative is 100y, okay? There's no y in this one, so we're going to get a 2x squared y. And of course we're integrating y squared, we get y cubed over 3, and we put the negative signs where they belong. Okay? And that expression has got to be evaluated at the lower limit x squared, the upper limit 8 minus x squared. So we replace this expression with what we get when we subtract the lower limit from the upper limit. And I just did that term by term. Y will have lower limit x squared, upper limit 8 minus x squared. That's multiplied by 100, so we have 100 times the quantity, upper limit minus lower limit. Okay, replacing y by upper and lower limit, subtracting the 2. So we have 100 times the quantity, 8 minus x squared, minus x squared. And then 2x squared y, it's the same thing. We're going to factor out the 2x squared, it's minus 2x squared, and then it's just got y from the lower to the upper limit. Again, we're going to get then 8 minus x squared minus x squared. And then we subtract 1/3 for this, 1/3 of y cubed evaluated between the two limits. So we're going to have negative 1/3 of upper limit 8 minus x squared cubed, lower limit x squared cubed. Now we simplify that and we just get a simple polynomial function of x. It's going to have, I believe, a 4th power or 6th power in there because of this term, but it's just going to be a polynomial in powers of x less than or equal to 6, and that's easy to evaluate from x equals negative 2 to 2. Now, what you have to see is that if the x integral is on the outside, the integral on the inside is going to be with respect to y, and our limits on y corresponding to whatever the value of x is have to be in terms of x, so that when they're substituted in here, all the y's go away and we end up with a function of x to integrate with respect to x. Now that's something you're going to have to get your hands on and do a couple of times, but if you work the problems that have been assigned, that comes about and you understand that pretty quickly. And if you ever do it wrong, it's going to bite you. You're not going to get rid of your variable, and you're going to realize that you've done something wrong, and that's it. Your outer integral is going to have constant limits. Your inner integral is going to have limits that are functions of your outer variable.